So, coming back to sinusoidal signals, there are various ways how we represent the sinusoidal signals. But before we move on to that, let me give you a small introduction regarding how sinusoidal signals are expressed or sketched. So, this is a simple sketch of your sinusoidal signal. I'll take this as the axis. This is time axis. It starts with 0. And this is the magnitude of the signal. So now I'll take a signal now. Okay, this is a sinusoidal signal. Now if you carefully see, this time is called as one full cycle. This is positive half cycle, this is negative half cycle, and this combination is your full cycle. Now the time taken for one full cycle is called as time period. It is called as time period and represented by the symbol t. And 1 by t is called as frequency. Okay. And 2 pi into f frequency is called as angular speed. And the units, for this one it is seconds, for this one it is hertz, and for this one it is radians per second. Okay. And the second thing which you should remember is, one full cycle always represents to 360 degrees. Okay. Now, one more thing. If I start with 0, then it is going to be 360 degrees. One full cycle length is 360. Now, this value is often referred to as maximum value. Now, I'll consider the signal as V of t. So, this is the maximum value of V. Now, this is the minimum value of t. I'm taking a uniform signal. So, Vm and minus Vm. Okay. These refer to maximum and minimum values of the sinusoidal signal. Now, sometimes the signal may not always start at 0, but it may start at some other points. If you carefully see, this is the time period. More or less, both are same, both are similar signals which I have drawn. But if you carefully see, this signal is starting at 0, this signal is not starting at 0. Right. So, in that case, what is the difference between the initial point to this point? How many degrees it is being deviated? Okay. Because I am measuring in terms of degrees. See here. This full cycle is 360, again 360, again 360 like that. So, if that is the case, then what is this particular duration? How many degrees? And that deviation is called as a phase angle. Ideally, it is 0 here, but here it is lagging by 30 degrees. So, I'll take it as, let us suppose if this is 30 degrees. Okay, so I'll take it as, this is Vm at an angle of 0, and this is Vm at an angle of minus 30. Sometimes the signals may be starting well ahead from the reference point. In that case, see, this is called as Vm plus 30. Understood now? What do you mean by phase angle? Okay, so a phase angle is nothing but the duration by which you are away from your reference points. Now, coming back to the representation of sinusoidal signals, sinusoidal signals are represented in two formats. One is a polar, the other one is a rectangular. Now, if I take the polar form, see, this is A at an angle of phi, where A represents a magnitude. In my case, it is Vm, and phi represents a phase angle, as I have already shown you in the previous one. Yeah, so this is the representation. What is maximum value? Vm, and the phase angle is 0. So here it might be Vm again, but here there is a difference. So I am taking it as minus 30. Here in this case it is plus 30. So this is magnitude and this is angle, phase angle, with reference to the reference points. Now, This type of representation is called as polar form. A at an angle of phi. Okay. See, phase angle refers to angular displacement or time shift between the waveform and the reference points. Normally, this phase angle is measured in either degrees or in radians. Choice is yes. Okay. When you do have two waveforms, just like this. Now, let us suppose if I do have two waveforms. One waveform is starting like this, and the other waveform is starting like this. See, this is your phi 1 for the first signal, and for the second signal, this is your phi 2. Phi 1 is the phase angle of first signal, phi 2 is the phase angle of second signal. The difference between these two is called as the phasor difference between the two signals. Understand? And that can be in terms of either degrees or radians. Okay. Now, while referring to two waveforms, the difference between them is called as a phase difference. Now, I'll show you. See, here in this case, A is leading B. Okay. Here in this case, B is leading A. In this case, if you carefully see, there is a phase shift of 180 degrees, complete 180 degrees. That's why they are just opposite to each other. Now, in this case, both the signals are overlapping with each other. There is no phase difference. Here, phase is equal to 0. Here, phi is equal to 180. Here, phi is equal to, might be 90 degrees. Here it is minus 90, approximately. So, like this, the phase differences will be there between the signals. Now, the other form is x plus j1. As already I mentioned there, I have taken Vm at an angle of phi, right? That is polar, and this is rectangular form, x plus j1. You can use an imaginary value j to represent the same thing. Okay, so this is the complex representation, complex number representation, x plus j1. So how to get this real part and imaginary part from this polar formats? See, I have mentioned the formula here. If I do have a and phi, then I can get imaginary part is a cos phi and real part is a sin phi. Or if I do have, it is in the format of x plus j, right? And if I want to convert it into a at an angle of phi, so immediately what I'll write is a is equal to square root of x plus y square and phi is equal to tan inverse of y by x. This is the mutual way representation, interchanging between polar and rectangular. Polar format is used in multiplication and division. Rectangular form is generally used for addition and subtraction. But nowadays advanced calculators are being used even at year level. Okay. So you may not need these rectangular and polar forms, but as an engineer you must know about these formats. And the other one is a direct representation of the sinusoidal signal. As already mentioned. Now if you carefully see, this is AM I'll take, and this is my phase angle. How much difference? In this case it is 0, but normally you are supposed to mention it if it is not 0. So AM phi is one format, x plus jy is another format. In both of these cases, if you carefully see, you don't use the frequency. You don't come to know how many times it is being varying for 1 second. So true representation of these signals is AM sine omega t plus phi. So shortly it is named as AM at an angle of phi, or otherwise x plus j. But its true form is AM sine omega t plus phi, where AM is the maximum value, omega is the angular frequency. See, omega is equal to angular frequency, and this is equal to number of cycles per second. Okay, and phi is the phase angle. Understand? So this is the way how to represent here sinusoidal signals. Okay, so the key things to remember: this is the true representation. A sinusoidal signal can be represented using. See, this is one thing. True representation. Shortly, you can write it as AM at an angle of phi, or otherwise you can use it as x plus j1. Okay. When to use this form and this form? This form is to be used for multiplication and division. This form is to be used for addition and subtraction. Okay. Now, when you are trying to add or subtract sequence, which form you are supposed to use? Rectangular form. Now, let us suppose there are two complex numbers, x1 plus jy1, x2 plus jy2. If you want to add them, directly you can add the real numbers and you can add the imaginary components. If you want to subtract them, see, real parts and imaginary parts. But whereas when you are doing multiplication and dividing, it's better to use polar form. See, this is the format of polar form. Now this is one number, this is another number. While multiplying, these are multiplieds, magnitudes, whereas angles are always added. If you are dividing them, magnitudes are to be divided, angles must be subtracted. Try to keep this in mind when we solve the problems on these things. So I hope that now you are capable of describing how sinusoidal quantities are represented in polar and rectangular form and also in its true form. So these are the lecture level questions. Sketch the waveform of a sinusoidal signal given by the equation 3 plus j4. See here, if I think frequency is not mentioned, you will take it as 340. Right. So in this case, how to draw the signal? So for drawing the signal, we must have a format of true formats, right? So true format basically is of AM sine omega t plus 1. Omega they have mentioned, it is 314. And AM and phi you do need. But what you do have? You do have x plus jy. So you convert it into AM and phi. How AM is obtained? Square root of x square plus y square, right? So it is square root of 3 square plus 4 square, 25. So it is 5. 40 is phi. It is tan inverse of y by x. So tan inverse of 4 by 3, it is 1.33. I think somewhere it will be around 43 or 53 degrees. I don't know, you have to try it, okay. So now this number is represented as 5 at an angle of 53. This is Vm, this is 5. So if I substitute here, what I'll get? My A signal is 5 sine 314t plus 63 degrees. Sorry, 53 or 63, whatever it may. So how to represent this particular signal? So it starts at 53 degrees and the frequency is 314, which means this is 2 pi f, right? So what is f now? 314 by 2 pi. I'll get somewhere around 50. And if f is 50, what is time period? It is 1 by 50. 0.02 seconds. So for next 0.20 seconds, I'll calculate it on the x-axis and I have to complete a sinusoidal signal with a maximum value of 5. Understood now how to sketch the waveforms. This is angle. This is a total time period. How it is obtained? From the frequency. And this is the maximum value. This is how you should draw the signals. Understood? Similarly, determine the rectangular form. So this is a true form, right? Shortly I can write it as 300 at an angle of 30. Now he wants rectangular form. How to get it? X is equal to AM cos phi. Y is equal to AM sin phi. So this is 300 cos 30. This is 300 sin 30. Now determine the phase difference between the signals. See, this is in sine. 300 sine 314t plus 30. This is 250 cos 314t minus 60. Both are having same frequency. So we can determine the phase difference. But the fact is that both are not sinusoidal signals. This is a cosine signal. So you should change it to sine. You know trigonometry. Cos is nothing but sine 90 plus theta. So I can write it as 250 sine 90 plus this one. So I'll get, this is also 30 degrees. Now if you carefully see, what is its phase angle? Its phase angle is plus 30. Its phase angle is also plus 30. Both, what is the phase difference? 30 minus 30, it is 0. Understood? This is the way. Ensure that both do have the same angular frequency and are in sine terms. And finally, sketch the waveform of the sinusoidal signal given by the following expression. Now this is an expression. You need to do it. You need to convert it into polar form. So you will get some value. A1 at an angle of phi 1. This one you will get A2 at an angle of phi 2. So what you are supposed to do? A1 by A2 is the magnitude. Angle is phi 1 minus phi 2. When you do have this one, I'll take this one as A, and this is at an angle of phi. So when you have this one, what you should draw? A sine 314, omega t plus phi. What is omega? 2 pi f. F is given by you. So 2 pi into f plus phi. This is here sinusoidal signal. And you should sketch it as we have done in question number 1. Okay. So we'll solve more problems in the class. Go through the video once again and come back to the class. Thank you.